Hello everyone, let's see if we can get all this graphing stuff into one little crash course here. I'm going to go through all the things that you are responsible for. So first, standard form of a quadratic is the one where you have ax squared, bx, and c. We did the quadratic formula, we factored, we solved some of these with square roots. But when you're graphing, you need to remember that the first thing you're going to do is find the axis of symmetry, which is that line that splits the parabola in half, and the formula you use is the opposite of b over 2a. That also gives you the x-coordinate of the vertex. Whatever you get here is the x-coordinate of the vertex. So to find the y-coordinate, you plug that in for x. So everywhere whatever you get, you're going to plug in for x, and then you simplify that. Usually your calculator does that part for you. So that'll get you the y-coordinate. You plug whatever you get for the axis of symmetry in, you simplify, now you have the y-coordinate of the vertex. A out front, A tells you a couple things. First of all, it tells you whether it opens up or down. So if it's positive, then the parabola is going to open up. If it's negative, it's going to open down. It also tells you the width of the parabola. If you have a big number in front of x squared, it's going to be narrower. And as that number gets smaller, it gets slightly wider over time. The last thing, to find the y-intercept, plug in 0, and in standard form, you will get c. So if you plug in 0 for x, those go away and you end up just getting c. But it's important you know all y-intercepts have the same x-coordinate, and it is 0. In standard form, these just go away and you can just look at it. So that's nice. So let's do one. If we're going to find the axis of symmetry first, the opposite of b, the opposite of positive 4 is negative 4 and 2a. So negative 4 divided by negative 4, x equals 1. The axis of symmetry is x equals 1. So you should draw a vertical line, x equals 1, and know that the x-coordinate of the vertex is 1. So to find the y-coordinate, I'm going to plug in 1. And I'm going to write down anything that I type into my calculator, and I will show you how to do this on your calculator just to make sure you understand how to use your tools. Negative 2 times 1 squared, that's not 1, 1 squared plus 4 times 1 minus 3 is negative 1. So when you plug in 1, you get negative 1. And that tells you the y-coordinate of the vertex is negative 1. And then the last thing I'm going to do is find the y-intercept. If you plug in 0, you can see this goes away, this goes away. So you're just left with the c term, which is negative 3. So 0, negative 3. 1, 2, 3 is right here. And I can reflect that across the axis of symmetry. If I'm 1 to the left, I'm going to go 1 to the right. And now I have 3 points. And I can draw my lovely parabola with smooth curves. Arrows on the end, looks good. Okay? That's it. That's standard form. Find the axis of symmetry, find the vertex, find the y-intercept, draw it. You got it. Vertex form. So vertex form looks a little different. You have A out front, and A does the same thing. It tells you whether it's up or down, and it also tells you the width. So A is the exact same, but in vertex form, you don't need to use a formula. You can just see the vertex is HK. So the vertex is HK. And since the vertex is always on the axis of symmetry, whatever H is the axis of symmetry. So this tells you the x-coordinate of the vertex and the axis of symmetry. Same thing on this one, okay? When you get 1, that is the x-coordinate of the vertex. But you can just look at it in vertex form. You don't need to do anything. But to find the y-intercept, this is a little trickier. You actually have to plug in x equals 0 and simplify that because you can't just look at it. A is not the x-intercept or y-intercept, H is not the y-intercept, and K is not the y-intercept. You have to plug in 0 for x and evaluate it to figure out what the y-intercept is. So be careful with that. So you see it's x minus h, and you have to think, like, what did they plug in here to get a positive 2? They plugged in negative 2. That's why it's written as a plus 2. So the x-coordinate is negative 2, and the y-coordinate is just negative 3. That is the axis of symmetry as well, negative 2. So my axis of symmetry is right here. And now I can go to the vertex, negative 2, negative 3. And the last thing, to find the y-intercept, you have to plug in 0 for x. Okay? So I'll show you, this is 4 minus 3 is 1. But if you use your calculator, 0 plus 2 squared, 0 plus 2 is 2. 2 squared is 4. Subtract 3, you get 1. So when you plug in 0, you get 1. And that's right here. And I'm 2 to the right, so I'm going to go 2 to the left. There we go. And now I can draw my smooth curve parabola. Pretty good, pretty good. So again, the trick to vertex form, it's easy to find the vertex and axis of symmetry. You got to be careful and actually plug in 0 to find the y-intercept. Domain and range. So domain, we're looking left and right. So I'm like, okay, what's the furthest left I go and what's the furthest right I go? This is -1 right here, x equals -1. And this is x equals +3. So in interval notation, the way we say that is -1 to 3 with brackets because they are on the function. Or it's not a function, but they're on the relation. The range is similar idea, but we're going up and down now. So the smallest y value is 1, and the biggest y value is 5, so 1 to 5, and we use brackets. Domain is x's, so this first x value right here is 2, and since this thing goes forever, it doesn't have an arrow, but I think it's applied. It goes forever to the right, we're going to say 2 to infinity. And since you can't count to infinity, we're going to put a parentheses there to say you never get to infinity. But 2 is on the function, so we'll use a bracket. And for the range, the smallest y value is 1, and it goes up forever, so that's 1 to infinity, again, parentheses, and it hits 1, so we put a bracket there. Okay, that's just domain and range, left, right, up, down. We're trying to figure out what we should see on the graph. Now, converting. So convert from standard form to vertex form by completing the square. I like to draw the pictures, so I'm going to make one of my little square things for completing the square. If you don't like to draw the picture, that's okay, but I like to see it. So let's see. We're going to do that, and then we're going to screenshot it, and I can draw on it, and this can go away, and I need another one. So boom. All right. So to complete the square, the first thing I'm going to do is make sure that this thing is set up, and I'm just going to say y plus something. Actually, I'm going to add that 1 to both sides. So let's add 1 to both sides. Y plus 1, and I'm going to leave a blank. X squared plus 6x plus something. Okay, if you're consistent, we'll do them all the same way. Now I'm going to complete the square over here. So half of 6 is 3. X plus 3, x plus 3, which means this corner, 3 by 3 is 9. So add 9 to both sides. On the left side now I have y plus 10, and on the right side I'm going to factor x plus 3 squared. But remember, you don't have to actually factor it. If you're drawing the picture, it's x plus 3 times x plus 3. So we just write it x plus 3 squared. And now the last thing, if you're trying to get it into vertex form, we're not solving here. We're just going to move this 10 back over. So now it's y equals x plus 3 squared minus 10. That is the vertex form. And just because I think it's really good practice, I'm going to actually show you this in both forms. So I have x squared plus 6x minus 1, and then the other one is y equals x plus 3 squared minus 10. So if you look, here's the function in standard form, x squared plus 6x minus 1, and you can see the vertex is negative 310. So right here, when I graph this one, see how they're on top of each other? That means I know I did it right. Okay, can I make it so they, there we go. See, I know I did it right. It's the same function in two different forms. Let's do the same thing here. Let's move that 3 over. So y minus 3 and leave your blank. X squared minus 8x plus something. And I'm going to complete the square on the right side. So x minus 4. Okay, half of negative 8 is negative 4. So the corner, 4 by 4 is 16. So I'm going to add 16 to both sides. And now I have on the left side y plus 13, and on the right side x minus 4 squared. The last thing you need to do is just move this 13 back over. So x minus 4 squared minus 13. Okay. That is the same function in two different forms. We have it in standard form right here, and now vertex form. So that's going from standard to vertex form. Now we'll go the other way, and this, you don't need to complete the square, you just got to expand. So when you do this, let's do x minus 1, x minus 1. We're just going to FOIL, ignore the 2 for now. So I'm going to ignore the 2. X times x is x squared. Minus x is minus 2x. And negative 1 times negative 1 is positive 1. Now I'll distribute the 2. 2x squared minus 4x plus 2. And then you have the plus 3 on the end. Combine like terms. 2 plus 3 is 5. Okay, so there's the vertex form, there's the standard form. I'll do one more. Expand the x minus 3 first. So leave the negative 4 alone. X squared minus 3 is minus 6x, and negative 3 times negative 3 is positive 9. Distribute the 4. Negative times negative is positive 24x, and negative 4 times 9 is negative 36. And then last thing, combine like terms. Negative 4x squared plus 24x minus 38. Okay. Again, two different forms, same function. So if I said, what's the vertex? Well, I would look at vertex form and say the vertex is at 3, negative 2. If I said, what's the y-intercept? I'd look at standard form and be like, the y-intercept is negative 38. Okay, so there's a reason that we have both forms, depending on what you're trying to do. One is better than the other. But if you guys can go through this, and you can go through your study guide that I give you, you guys should crush this test. So make sure you hit that like and subscribe.